In item 3 of the first test of fall 2015, we are finding the moment with respect to point B caused by the 50-pound force on the hammer. So point B is the embedment point down here with this nail. And so there's a lot of ways you could begin to try to work out the problem. When you see complicated geometry that we have set up here, that is probably easier to replace the force with its rectangular components. And then this probably becomes much easier. So that's what we'll do first, is break that force down into its x and y components. That fx will be equal to 50 times cosine of 20 degrees. So we end up with, for the x component, 46.98 pounds. And for the y component, then end up with 17.10 pounds. And then we can find our moment arms. And for that, then, we go take a look at the geometry that we have. We have an 8-inch radial distance from the point of application force to point A. And so that makes me think about doing some sort of a right triangle. And so, oh, hey, that means that this total perpendicular distance from the x component force down to point B, all that piece of y, that's going to be equal to 8 times cosine 20 degrees. That's this portion here of the right triangle. And then we'll add to it our 1.75 to get the total height. And that will give us 9.268 inches. And then our x component, then, that we want, x distance, x moment arm, that distance right there, well, that's just a subtraction then of our 2 inches from the base of that triangle. Or 0.736 inches. And now we can calculate our moment. Total moment will be the sum of the parts. And that will be, since they're I pin about B, both of these two are going to make a clockwise rotation. So Fx times its perpendicular distance dy plus Fy times perpendicular distance dx. And that would be the 46.18 pounds times dy. That's 0. Oh dear, I got that wrong. 9.268 inches, pounds, plus our 17.10 times 0.736, and add it up, and we get 46 times 9.268 plus 17.20 times 0.736 equals 447.996. That's of course inches, and that's a ridiculous number to report of that kind of precision. So our moment that we seek here is rounded to 448.10 inches in a clockwise direction. That direction is also important, and there's your answer.